We're going to continue talking about types of quantum number problems. So in number 2, it's asking what is the maximum number of electrons that can have the following set of quantum numbers. So an n equal to 2 and a ms, which is the spin, equal to negative 1/2. Any quantum number problem, I like to take a look at my periodic table. So let me bring up my periodic table. So we want an n equal to 2 and a spin, so an m sub s, equal to negative 1/2. So right away, I can use my periodic table to help me narrow this down. So I'm going to circle or highlight everything that could have an n equal to 2. So it could be these over here in 2s or these over here in 2p. So of these, which of these would then have a m sub s or a spin of negative 1/2? So I'm going to change my color here. Okay, so it's going to be the second ones because they're going to be the downward facing arrows. So it's going to be Be if we were thinking of it that way. And then it's actually going to be oxygen through neon. These are the elements that would have the downward facing electrons. So if you think of the 2s, this first one would be lithium. The second one would be beryllium. So that's 1. And then 2p, the way that we add the electrons, we would have borons, electron, carbon, and nitrogen before we go back and add the downward facing electrons. So in total, we have 4 options here. There could be 4 different electrons that have an n equal to 2 and an m sub s equal to negative 1/2. For the last question here, it's asking which of the following quantum numbers would not exist or would not be allowed in the atom, so it can't exist, in other words. So what we're going to do, I like to just look at my periodic table and see if I can find it. So n is equal to 2, so we already said that that would be in this, either over here or over here. So L is equal to 2. Well, L is 2, so if n is equal to 2, it's the second energy level. If L is equal to 2, that means that it's the D block. Well, I don't have the D block highlighted, so this one is not possible because of L is equal to 2. So if I wanted to support this, I could say like no D block. With a second energy level. So you just need to say like why you couldn't do it a little bit. So we don't have a 2D, in other words. So then let's take a look at the next one. So we have an n is equal to 4. So that's the 4th energy level. So we do have to think about this a little bit. N is equal to 4, so there's several areas we could have. So we could have the 4s, the 4p, the 4d, which is actually in the 5th period, or the 4f. We have lots of options here. So L is equal to 2, so that's telling me it's 4d. So it's going to be in here. Okay. And we have an m sub L equal to negative 1. So if I drew out the 4d, I would label it negative 2, negative 1, 0, positive 1, positive 2. So it looks like this one's I have the possibility to have. I could have the m sub L equal to negative 1. It doesn't tell me a spin, but I'm assuming I'd be able to have it. So this one would kind of get a green check mark because this, oops, that's a red check mark. A green check mark because it is possible. So that one is possible to exist. So that's why I like to use the periodic table to help me. You just have to remember where does 4D start because it's a little bit different, and where does 4F start because it's a little different. Next one, we have n is equal to 3. So that's the 3rd energy level. So I have here the S, the 3P, and the 3D. Okay, all of those are possible. My L is equal to 1, which is indicating it's the P sublevel. So it's going to be over here. And then m sub L is equal to 0. So I have 3 possibilities here for my 3 P. I would have -1, 0, and +1. So 0 is entirely possible. This one's also possible, so it gets a check mark. And the last one. Okay. So we have the 5th energy level. So I could have here, whoops, here. Oh, nope. Should have ended there. And here. Let's use another color to make that a little clearer. So let's use the red. And then the last one is the F way down here. For the 5th energy level, L is equal to 0, which indicates it's S. So we're going to focus right here. Our m sub L, it says, is equal to 1. Well, I have 5s. Uh-oh. I only have 0 there. So this one is not possible because of the 1. Oh, it should be red. So this one gets a big red X because if you're in the S, you can only have an m sub L of 0. In order to have an m sub L of 1, you would need P, D, or F, so 1, 2, or 3. Okay, so it's kind of going through the process of elimination. I think using the periodic table is the easiest way to do it. If you could just figure it out by looking at it, that's fine too.